of partnerships. We are an independent nonprofit organization serving as the innovation hub for robotics, AI, and smart connected devices. In MassRobotics, our aim is to set on bringing together new and existing organizations to nurture and promote economic growth and innovation. Our mission is to grow the robotics ecosystem and support the wide adoption of robotics. Industry-focused events like this one, we find ourselves today, are one of the many ways we support the robotics ecosystem. So, welcome to our third Robotics and Construction event. The first event we had was in 2018, and a very short story about that. Rick, who is going to speak in a few minutes, he and I were having lunch across the street, and we were kind of discussing about what Autodesk and MassRobotics can do together. And through multiple chat, we said, you know what, construction is growing as an interesting sector for robotics deployment. And then Rick said, it would be nice to do a summit around robotics and construction, and we bring all the stakeholders, the investors, the researchers, the entrepreneurs, the large corporates, everyone who has a role in construction. So we felt it's a good idea, and we started doing that. The first event was actually hosted at Autodesk in their amazing facility across the street. And then we had the second one during COVID. It was a semi-virtual one in 2020. And today, this is the third one. We're very excited. We have close to 200 people online and an amazing audience here in person. So why construction? Construction is a very interesting sector. And the reason for that is, according to McKinsey, every year there is almost $10 trillion invested into construction. However, this is not coping with the demand that we're seeing. So it's an industry that has a growing demand. And on the flip side, we are seeing a decreasing workforce. So if you think of graphs, you have a graph going all the way up in terms of demand. In terms of labor, you're having a labor going down. So how can we fill this gap? One of the most effective ways is actually using technology, using robotics, using automation to fill this gap. Hence, the increasing trend that we are seeing now from construction companies that have been deploying, have been testing, have been investing heavily over the last few years in robotics and robotic solution. So, having said that, look at my notes. This event will include discussion with investors in the construction technology, and it will highlight high-impact solutions and showcase several potential new technology solutions. The goal is really bridging the gap between the construction community and the opportunities, needs they have, and what the innovation and technologists have to offer. We have an amazing lineup of speakers today. We will hear from investors in the build tech space. We will learn about challenges of the industry and the promising companies they have invested in to solve some of these challenges. We will also listen to tech pitches from startup companies pursuing innovative technologies to help solve some of these technologies. So before we begin, some housekeeping items. This session is being recorded, so everything is on record. If you are interested in downloading the slides, you can go to the handout tab on the right side of the control panel, and you will find a link where you can download the slides. Obviously, people in person, you cannot do that. Due to the number of presentations and the amount of content being shared, we decided not to take questions live. However, feel free to share all of your questions on the chat box, and we are going to share these questions with the relevant companies or speakers, and we will ask that they would reach out to you directly and answer your questions. I personally, and on behalf of MassRobotics, I would like to thank Autodesk for their amazing support and partnership from the beginning. Rick has been a close contact of us since the inception of MassRobotics. This is back in 2014. He was probably among the first 5 people I spoke with when just kind of we were starting MassRobotics, and he shared a lot of insights about the experience that Autodesk had in the space. So I'd like to thank Autodesk, Rick, and all of his team. and hopefully we continue the amazing work that we have been doing together. I would also like to thank Danfoss for participating today and kicking off the second half of the session. Danfoss is one of our more recent partners, and hopefully we can build a long-term relationship similar to what we did with Autodesk and the other 40 partners that we have. So Peter is going to speak to us later in the day about what Danfoss is doing and what they are seeing in the space. And now it's my pleasure to introduce Rick Rundell, Senior Director of Autodesk Research Programs, to give us a look at the future of construction. Rick, floor is yours.
Wow. It's been a long time since I've been in front of a room of, physically in front of a room of people. So this is very cool. It's great to see all of you here in person, and hello to all of you that I can't see that are dialing in online. So I am very excited about this topic. I'm an architect by background, a building kind of architect, not a software architect. And when I was in practice, I did buildings mostly for science laboratories, biomedical buildings, crazy, expensive, complicated, really interesting work that required a lot of drawings and a lot of drawings. And my first exposure to automation and robotics was when I came across a robot that actually did those drawings for me. So at the time we were using ink and pens to draw on Mylar, which was then allowed to be reproduced. And I would I would lavish days on making a drawing. And when I got into a practice that had a CAD system and a pen plotter, suddenly I realized, well, I've got a robot to do this drawing for me. And that machine could do an hour is what it would take me days to do. So that was my first exposure to automation. And if I had been particularly prescient, I might have thought, oh, well, someday maybe machines like this would make the buildings themselves instead of just making the drawings for those buildings. So I can't claim to that insight, but in retrospect, maybe I can. So I definitely got the tech bug and the insight into automation at that point. And at some point, I became very impatient with what technology was doing in the industry and went off and I joined a software startup that was doing some new software for architects. And eventually that became part of Autodesk. And I spent my early years at Autodesk evangelizing what technology could do for buildings in the form of what at the time we were calling building information modeling, which is now such a ubiquitous term that everybody knows it. And then around 2008, I ended up working on building our first product for using cloud and mobile computing technologies for the construction site. So we had realized, we had an insight at that point that suddenly with the advent of tablets and mobile phones and cloud computing, that the data that was coming out of our design tools could actually be delivered to the construction site. So maybe instead of walking around with a bunch of drawings, people could walk around with a tablet or something and see what they were doing. So there was and that has since then, become pretty commonplace. That kind of technology is widely deployed in construction now. In doing that, I acquired actually 5 startups and put together that product, which was the first iteration of what we call BIM 360. And I got very interested in what the innovation ecosystem and startup space could do to drive innovation in a company like Autodesk. So I realized, it was hard for a lot of reasons that maybe could have been made easier if we had just been more thoughtful about how we engaged with that community over time. So I ended up creating an innovation program and eventually led to building out the innovation lab that's just down the street here. And that opened in 2016, and in 2018, I ended up managing a network of similar facilities at Autodesk. We call them the technology centers now, and so my team leads that group. More importantly, let's see, I'm forgetting to change some slides. There, that's my title slide. So these technology centers, we have 4 of them. I manage 3 of them, and then we have sort of some satellite facilities around the world. So, so my team manages those 3 red dots in North America. And more importantly, they manage a network of innovators that we invite into these spaces to do their own work. So startups, we host startups as residents. We have academic teams come in. We have research and project teams from industry, construction companies, design firms. And this provides us with a lot of insight, a particular kind of insight, but a lot of insight into kind of what the future of the industry might hold. We've had thousands of people in this program since 2018 from over 450 350 organizations from all over the world, though primarily North America. And it's some examples and cases from this program that I want to share with you today to set some of the context for the conversation that we're going to be having a little later today with investors in this space. So a couple of topics, loosely organized. We're going to look at what the kind of application of robotics that we've seen for on-site value add. We're going to look at then where robotics can apply in off-site kind of applications. So you're sort of bringing in one case, bringing the factory to the site, you might say in the first case, and in the second case, bringing the building, more into the factory. And then I'm going to touch a little bit on the technology that we've seen emerging, just lightly touch on that. That is making some of this possible. So there's sort of two aspects to this on-site based opportunity. So there's taking on tasks that are already happening on a construction site and simply automating them. So taking what somebody's doing and then getting a robot to do it in simple terms. So that's sort of one category. And then another category is actually replacing an entire construction assembly with one that is more easily automated, or is possible to automate, and really changing how the construction is done. So this first example is a robot collaboration between a company called Windover Construction, which has been doing a lot of innovation in the technology centers, collaboration with them in an organization called RCML, which is a startup out of MIT, and the RCML stands for Robotic Control. Meta language is actually one of those technologies that's sort of making it easier to interact with a robot. And this is actually a pretty common idea, that you put a scanner on a robot and you let it run around a construction site and it captures information about the construction site. In fact, the Boston Dynamics is positioning their Spot robot, very similarly with some Faro hardware to do this kind of work. What I loved about this example was that they took that a step further. And if you look there sort of on the ground behind in the larger picture, they actually have a little can of spray paint that can draw a line on the site or draw a line on the floor. So they're actually doing the layout. So they might be doing layout for, here's where I want to dig a trench, or, here's where the edge of a partition should be set, or something like that. So So I laughed when I saw this, because I thought immediately of my pen plotter, and it's like, wow, now they're actually plotting drawings right on the construction site. How cool is that? So that's what this team is doing. This group, another, one of the application of robotics on a construction site is often characterized as taking care of the 3Ds, right? Dull, dirty, and dangerous. I think I got the right 3Ds there, but basically there are very few duller and dirtier and more dangerous jobs on a construction site than tying off rebar. You can imagine a worker trying to navigate their way across a mat of rebar like this and having to hand install all of those ties. It's drudgery and kind of a pain in the neck. And so it's ripe for automation. In fact, I think we're going to be hearing from a startup a little later today that's applying a gantry-based system to this very problem. SkyMule is applying drones to this problem. So they're using cloud computing, machine learning, computer vision, and then the autonomous drone technology to characterize the intersection that the drone is looking at, figuring out what kind of tie to apply to it, and then actually putting a tie there, and then flying on to the next case. Raise Robotics, I think, actually is relatively new to our network, and they may be in the audience today, and if they are, I apologize for mangling your pitch deck that you gave me, but there it is on the screen. And they are automating another dull, dirty, and dangerous task, and that is applying the brackets that go on the edge of a slab or on the end of a building structure that are used for mounting the curtain wall system, the exterior enclosure. And this is actually a very important part of the quality of the building, because it's that moment, it's the adjustability of that bracket, the installation of that bracket, that mediates between the relatively rough tolerances of the structure, the edge of the slab, and the much closer tolerances and precision that's required of the exterior envelope of the building. So that's when the building kind of gets precise. So it's important quality. It's pretty much always on the edge of a slab, so it's a little bit dangerous. And it's also, because that's the system that keeps the weather out of the building, it's important that it be done well. So another quality in that sense. Well, the video that you saw here was them just sort of prototyping out with the robot how that work would be done. When a number of years ago, actually, when we were looking at how could 3D printing be applied to construction, there was a number of people who were talking about bringing 3D printers to construction sites to custom print those brackets. So instead of having a bracket with a lot of adjustability in it, you would fabricate exactly the bracket you needed for the particular condition, and that would eliminate a number of points of failure in the adjustability. I don't know that anybody ever actually followed through on that, but it shows that was an idea that people, this has been a pain point in construction for a while, and it's something that people have been looking at. So the other sort of category of on-site automation is where you just simply replace a building system with one that's more easily automated. And the examples I have here are our 3D printing of buildings, right? Which was sort of an easy idea. I take a MakerBot, blow it up, scale it up, start printing a building. And I have to admit, when this company, Apis Core, started working with us a few years ago, I was a real 3D printing in concrete skeptic. To me, it seemed naive to think that something the size of MakerBot was something that you could scale to the size of a building. It wasn't really clear to me that it was solving a problem that existed in the industry. Is this making buildings cheaper or doing something to increase the quality of the buildings? And honestly, cement is one of the big carbon footprint problems in our industry. And taking a construction system, wood frame construction system, and replacing it with a much more carbon intensive material in the form of cement. And at that time, 3D printing of concrete usually meant 3D printing of cement. There was a lot more cement in that than you would find in a conventional aggregate wall. Just seemed like a terrible idea from a climate change process. Since then, I don't know if I'm entirely a convert, but I'm a little bit less of a skeptic. There's been some really great material innovation that's been done in terms of how to actually use concrete for carbon capture to sort of offset the production of cement. There is more effort to get solutions like this integrated into the supply chain for construction. It's starting to feel a little bit more real. We may see buildings, you may be able to drive by a building. I imagine someday, driving through the neighborhood and saying, "Oh, that's a 3D printed house. That's a 3D printed house," right? Just like you occasionally, run across, projects, houses that have a unique construction, but they're common enough that you can see them in life. So Apis Core started working with us a few years ago towards building this. At the time, it was the largest 3D printed structure. It was a building in Dubai that you see here that's in process. One of the things that I most appreciated about this group is that they met a team from a construction company in our program as well, who was also in the doing work with us, Thornton Tomasetti, and they realized that in order to get anywhere with their project, with their technology, they needed to be accepted by building codes. And whenever you're in a conversation, I'm sure all of you are, pretty often in a conversation about innovation in the construction industry, eventually you get to the, okay, now we're going to grumble about building codes and regulations as, limiting innovation. And it always feels, and at that point, you can either roll your eyes and say, okay, nothing's ever going to change, or you can do something about it. And I don't, I guess as an architect, I don't have a lot of patience for that grumbling. Those building codes exist, those regulations exist for a reason. They keep us alive and healthy. If you screw something, like the reason every one of those codes exists is because at some point somebody died, because people didn't build that way. So it's a little presumptuous to say, oh, the industry is so conservative and it'll never change because these regulations. The industry has paid a price for every one of those regulations. So I really appreciated what this team did, and that is they worked to get this system approved basically under the same criteria as concrete masonry units. So take a conventional concrete masonry wall and compare it. You can see in the middle there is a diagram. Build a comparable structure out of 3D printed, and then test the heck out of it. And that's what they did with a load cell, and now they're permitted. They're sort of credentialed for conventional construction. There's probably still a conversation with the building code official at every site, but at least they've got the documentation to back it up. And here's where they are today. That's other pictures of their project in Dubai, but they've opened a showroom in Florida, and marketing their product to people who might want 3D printed houses. So that's where those folks ended up. AI Space Factory was really another interesting group that was working around the same time as Apis Core, and what they were debugging their process here, and they were entering the NASA Mars 3D printing habitat competition, which was actually sponsored in part by Brick Plus Mortar. I think we have somebody here today, but so they were printing with a material that mimics, lunar or Martian regolith, regolith is basically eroded rock, which is what you get if you don't have, weather processes on a planet that create soil. Incredibly abrasive stuff that is very hard on an extruder. So they were debugging their process to make this entry for the competition. And here they are at Caterpillar, actually in the competition. This is what they were working towards. And then, this was a pretty interesting competition. There were only, I think, 2 people and 2 teams entered in the final, but there were, probably 60 teams headed in that wanted to do something. So it was a tough assignment but it fostered a lot of innovation, I think, in this space. You see them here. And then when it came time to get rid of it, they tried to crush it with that excavator on the right, when it actually had lifted up off of its treads. The treads lifted up off the ground as it was trying to smash this thing, but eventually it did break and they threw it away. But it's really fun, really interesting project. What they're up to these days, this is fun for those of you looking for sources of funding. So they're focused on the design of, you saw that beautiful rendering at the beginning of this segment. They're focused on the design. So they're offering their structures in the metaverse. So you can get it through a non-fungible token and NFT. You can buy one of their structures. This was a special Valentine's Day edition set. And so I don't know how it's going. I just found this on the web. I just followed up to say, I wonder where they are today. So this is where they are. So they're selling things on the metaverse, in the metaverse to raise funds for further research. So that's what they're up to. So those are, a few on-site cases. And now let's move on to what's kind of going on and offsite. And so the picture on the side of the screen here is Factory OS in the Bay Area, California, and we're working with them. And it's this idea that you're going to build parts of the building in a factory is not that unusual. And what the opportunity there really boils down to is machine tending and some of those kind of processes. So it's pretty well understood. The challenge in those processes, I think, is that they need to be changed a lot, right? So it's not like you set something up and you make 1 million cars. You set something up and you make a few modules and then you have to set it up again. So tools that make the process easier would be important here. But that's really the kind of, I think, incremental opportunity for robotics in that kind of setting. We've had some work going on in the tech center that I think is relevant in this area. Perkins Will, which is a global design firm, has been working with us. They've probably done 6 or so projects with us, and they actually placed a roboticist with us for a couple of years to do research on their behalf. So we've hosted them. They've been doing work in novel applications for wood in construction. There's some advantages to wood from a sustainability point of view. And they were particularly interested in nail laminated, taking conventional dimension lumber and nail laminating it up to larger to larger structures. And they originally started with steel nails, and that was a problem. Steel nails actually, when you really collect a bunch of them, they're actually pretty wiggly. So they got, their structures were a little too flexible. And so they moved to wooden nails, which is actually a thing. So it was pretty interesting. And this is what this pavilion was, what the researcher was working on this pavilion. There are some advantages to large sections of wood in terms of fire resistance. It chars and then it doesn't burn. This particular project is not a good example of that. You'll see it looks like it's something that could burn pretty easily just because of the way it was built, but it was certainly beautiful. And they built out a robotic fabrication cell to fabricate these items. And I think there's a video here coming up about exactly how that worked. And in the sort of better tools category in the upper right-hand corner, there you see a tool called Machina, or Machina, potentially, which is an open source library that makes it easier to basically tell a robot what to do. So that's what this researcher was using that in order to program this sort of one-off cell. But it took that pile of lumber that you saw Hakeem rolling into the cell, and it just takes all of that, cuts it to length, moves it to the to place it on the pavilion assembly, and then nails it. It's a little slow, but so you get an idea of what that's working. But it's, it's a fairly conventional robotic fabrication cell. But the key here is that by using the right tools, he was actually able to get this cell up and running in a reasonable amount of time. So imagine this being something that you would have in a factory that's doing modular construction. It's like, there's certain assemblies that need to be put together. You can just get something like this, making those for you, and then bringing them and assembling them into the final, volumetric modular piece. Here's the project on site. This was for a project for Green Build. And then my last example here, this is interesting. It's some similar kind of application of robotics from a fabrication process. So this was actually a design studio at the University of Southern California, and they were exploring an idea called generative design. So generative design means that the designer, instead of actually drawing the thing itself, provides some constraints and conditions that the design has to meet, and the computer goes off and sort of cranks through a bunch of options and says, okay, well, you could do it this way, you could do it this way, you could do it this way. And in this case, there was some structural, there were some bearing points and some structural criteria. And this is, if you Google generative design, you'll find, a lot of the outcomes look like this. With a little tweaking for aesthetics, you get something that's, very fluid, flowing, kind of organic looking design, but really hard to build. There's a reason that, buildings are square and, walls are straight. It's because those are easy processes. When you do generative design at a manufacturing or product scale, you get something that, usually you 3D print, and you can, have a lot of flexibility there, or sometimes, you can mill something out of a solid block of aluminum and get some, some kind of very efficient looking structure. But at building scale, a different approach was necessary. And so interestingly, they got the design, and then they decided to take on the challenge of actually fabricating that. So they approached us and said, can we use your facility to do that? One of the challenges is fabricating these really complicated joints, and so which would require jigs to do, which themselves would be complicated to make. So in this case, the application of the robotics is for the work holding. And I love this video because usually you see the robots doing the welding, right? But here, actually it turns out to be much more effective to have, this, probably a student who's been shown how to weld, poke their head into the cell and do the welding while the robot is doing the work holding. That may say something about the relative cost of labor of students versus manufacturing environments. But so they were able to actually build this pieces of this truss. What they did is basically built the whole bridge and then cut it at places where it would be easy to put back together. So cut it between the joints, right? So get all the complicated stuff done, and then disassemble it so that you can just plug it back together on site. And another piece of tech they used here is actually, this is running in Maya, which is an Autodesk product that's often used in the entertainment and film industry. And here it's used to drive robots for the purposes of filming, sort of complicated dynamic scenes. So the film Gravity, where Sandra Bullock is, spinning around. She's actually not spinning around. There's a robot that's spinning the set around, behind her. You've probably seen that example. So here you see, this is how it would be applied in the film industry, filming, maybe on a Star Wars set. But they use that same, they use this same tool to drive the robot to do that work holding. Both of the two that I've just showed you are open source libraries, so very easily accessible. And then here's the project installed on site, packing it up on a truck. You'll see actually both this and the Perkins and Will project had, they both had done studies about, well, how do we load the truck up with this thing? So that's one advantage of having a model. So on-site opportunities, off-site opportunities, better tech, a couple of sort of better tech things I wanted to mention that I didn't have material on otherwise, but that are local here that I think are very promising. And there's probably a lot of other tech like this. This just happens to be two that I'm aware of. Is real-time robotics, which is doing automating the motion for robots, and I think they're probably within a few miles of here. I'm not sure if anybody knows. Yeah, and then Humatics is doing, David Rundell and his group and MIT are doing some remarkable work in microlocation. And so especially on a construction site, when you're dealing with that kind of dynamic environment, the robot kind of knowing what's going on around it and being able to locate things seems like a key tech. So that was something that is probably going to play in this space at some point. So I wanted to close with one more project by Perkins and Will. This is a mobile robotic architecture assistant for architectural design, MRAD. And what this is a platform that their researcher designed, basically a toolkit on a cart that rolls around an architecture firm and does things that architects need done. So it will cut, 2D museum board. So if you're making a model and you have all these intricate things you want to cut out, you can set it up and it'll cut that out for you instead of you doing that with an X-Acto knife. It'll hotwire foam for making massing studies of buildings. It does in the upper right there. It'll do sun angle studies, right? So put the building model there and say, okay, where's the sun going to come from at this time of day? And the robot will move it around. None of these things are, groundbreaking or hard. You could do these with laser cutters and there's other applications. So the purpose isn't really to make architects more effective. What the purpose is to get designers thinking about what it means to have this kind of technology available in the world. How can they? How will this technology applied to how buildings are built? How should that affect how they design buildings? And I loved this project because it feels to me like in a number of ways, we're still in the horseless carriage kind of phase of robotics and construction. And by that, I mean, when cars first came out, the only thing we knew to make them look like was horse-drawn carriages. So they were horseless carriages, right? And then eventually we got to Bugatti and, all the other expressive automobiles that we have. So right now, we're designing buildings in a way that it does not reflect the opportunities of some of the processes that are available. So there's an opportunity, and we're choosing to automate things that are just being done by humans for the most part, right? It's like, can I take something a human's doing that's dull, dirty, and dangerous and automate it? And that is, 3D printing of buildings is sort of a step beyond that, but it feels like there's a whole different way of looking at a systems level about how a building goes together that could be an opportunity. And I don't have any good idea what that looks like, but I ask myself, what would it be if we were designing for automation? Just like, you design for manufacturing, designing for construction. What if you designed for automation? What would a building look like that? and what kind of opportunity would that provide in our industry. And that's what I have to say. Thank you for your attention. So now we have some people who really know what they're talking about to come up, and I'd like to invite our panelists, Gregg, KP Wanlizu, and Alice up to join us at the front of the room, and we're going to have a discussion about what they see as the opportunity for robotics. Oh. Okay. All right. Did I go long? All right. We have 3 microphones for 4 people. So you guys, it's gonna be like Hunger Games up here.
We need some love.
Yeah.
Thanks. Sharing is good.
All right. So I'm going to kick this off just by asking each of you maybe to introduce yourself a bit, share with us some things about yourself and about your background and your company, and then something you've seen recently, maybe a company you've talked to recently that you found particularly interesting. So something that's maybe a little different or a different kind of opportunity. And I'm just going to go left to right this way, starting with Alice.
Awesome. Great. Put me on the spot.
Yeah. Well.
I think this is on now. Hey, everyone. Thanks for joining physically and virtually. I'm Alice Leung. I'm an investor at Brick and Mortar Ventures. We're based in San Francisco. We do early stage investing in what we call the construction process. So that starts with design through pre-construction, construction, handover, commissioning, operations and maintenance. We're a small team of 5. I actually used to come from construction. So I worked at DPR Construction for a number of years, working with early stage construction tech startups. And it's kind of great to jump to this side where I get to work with all of these different construction tech startups from the investor perspective rather than the end user perspective. But I also work really closely with a lot of large industry partners. And I guess, I don't know, this is a hard one, interesting thing that I've seen recently. I guess the AI Space Factory thing, that was super interesting because I've been trying to dig into NFTs, Web3, and even the real estate metaverse, which I don't know, I'm still trying to wrap my head around that. It's still kind of nebulous to me, but I think that's new and interesting. So we'll see. I don't know. We invest in the physical world, so it's hard to transition that into the virtual world.
So I'm KP Reddy, founder of Shadow Ventures. We invest in construction tech generically, much like them. We focus on seed stage, small team of 6, all kind of serial entrepreneur types. I've built about 6 companies, civil engineer by background, been coding since I was 13. So we're more of the nerdy side. We care about defensible tech. We care about AI, actual AI, not fake AI, which is about 90% of what we see. And we do deep code review. And so we're, I would say, much less focused on revenue, but much more focused on what technical challenges are you really trying to break through.
Great. Hi, my name is Wanli Zhu. I'm co-founder, managing director of Suffolk Technologies. We are a Boston-based venture capital and innovation company affiliated with Suffolk Construction, a large general contractor also based in Boston. Suffolk does about $5 billion of construction work across the country. We started Suffolk Technologies in 2019 to invest in companies in construction as well as in real estate. So far, we've made 20 or so investments. We also run an annual program called Boost, which we define as kind of a company building, problem solving program for startups in the construction domain, where we gather industry partners along with Suffolk experts and work with companies in a condensed 8-week period to help them solve a business challenge. I'm new to construction. I come from an enterprise software and venture capital background. Have been a VC for 9 years prior to coming to Suffolk Technologies. And I guess an interesting technology recently was at Built Worlds last week, actually, and met a company working on autonomous cranes. And they're thesis is that human crane operators tend to work mostly with 2 dimensions at a time in terms of moving the crane load. If you apply machine algorithms to the problem, initially as kind of ADAS and then eventually full autonomy, it can help with collision avoidance and kind of safety guidance, because the machine will think simultaneously in 3 dimensions rather than humans thinking in 2 dimensions. So I thought that was an interesting concept.
That's one thing. Hi, I'm Gregg Wallace. I'm a principal with Building Ventures. We are a Boston-based early-stage venture capital firm. 4 of us are based in Boston, and then I'm based together with Alan Prager on the West Coast. We also look at the full life cycle of building, from designing through planning and building, also building operations and maintenance, thinking through the full life cycle of the building. We tend not to focus as much on prop tech. We all throw around these terms, prop tech, transactional element of buildings. We're interested in the building data and how the convergence across the building life cycle will increasingly occur, bringing further and further collaboration across some of the industry-defining companies that have typically characterized 1 or 2 of the major phases of the building life cycle. We are soon investing from Fund 2, which will be a $100 million fund. We look to make around 4 to 5 early-stage investments each year. Within our Fund 1 portfolio is Built Robotics. So we're about to embark on a massive infrastructure spending package, and Built Robotics is helping bring autonomy and collaboration across different machinery manufacturer types. For example, doing trenching activity in a more autonomous way. Previously, I spent most of the last decade with Hilti Corporation, based in Europe. So Hilti's a maker of power tools and fasteners, and increasingly looks at bringing software enablement to the tools and increasingly machines that workers are using. And I would say, you know, one of the fascination points I bring into interacting with teams is what it actually takes to have an interface between a software-enabled machine and the crew that is operating it, and doing so in a collaborative, mutual understanding, kind of feedback reinforcing, and socially responsible way. Since all of us here are probably advocates of technology, and we may find a mixed audience amongst the crews and unions who have physically built our country. So how do we do that in an also inclusive, collaborative way has been one of my interest areas. One of the teams that's caught my eye recently, actually one of the early investments of brick and mortar ventures, Canvas Robotics, was a team that I got to know over the last few years in San Francisco, and I actually got to tour their new facility last week. They raised a Series B capital investment last year, and they are bringing through an increasing number of construction companies to get drywall work done, and I think they've built a remarkable story. I think we'll hear from today in the audience a few more entrepreneurs who've caught my eye recently, so I'll save the thunder for them to share in a little bit.
All right, thank you. So we have a number of startups in the audience here in the room, and we have other startups, I'm sure, in our virtual audience, and I think many of them might be interested in hearing, what do you look for when you're going to invest in a particular startup? And KP, on our prep call, you mentioned that you had just made an investment, I think, in Icon 3D, and
yeah, that was actually about 3 years ago.
Oh, okay.
Yeah,
well,
so we were
not really news, but
yeah, they just raised a $185 million round,
right.
$2 billion valuation. So not too shabby for 3 years of work. But no, that was Fluent Austin. It was a 3-person company. For me, it was just, they were solving materials problems. They were solving robotics problems, some major computer vision issues. And I'd built a couple of robotics companies, so I was kind of very comfortable. Flew back to Atlanta and sent them money, which is kind of what you do. And they've gone from there. But part of it was that there were at least 6 kind of key technical things that they could solve and defend, and they were like really, really hard problems that I'd seen before, that they had kind of novel solutions for. And so our thesis was, are we going to live in 3D printed homes? Maybe, maybe not. But if they execute well, the technology will always kind of live on.
Yeah. Gregg, maybe what do you look for in an investment? Same question.
One, Yeah, the robotics is tough. There's so many elements and core capabilities the team needs to get right. So I think, building on KP's point, what aspect of that stack teams can benefit and stand on the shoulders of giants of so many different enabling technologies. So I also look for clarity of what enabling technologies are you using from the market, some of which have been around a long time, some of which may be brand new. And then what element are you and your team building that is kind of specific, unique, and may also include a defensible moat. So I think that's on the technology side. On the business model side, I would look for proximity. How quickly are you deploying? Are you able to perform real work and add value? Robotics tends to be more expensive, more capital intensive, and we're also looking for how quickly that team can also start to generate revenue and not just be a research project.
Yeah.
Can I add a?
Sure. Please.
The model we have at Suffolk is a little bit different in the sense that we look at the venture criteria that typical VCs do in evaluating companies. We also combine that with our ability to test the product on our 120 or so active job sites at any given time. So we're able to impedance match kind of the right job with the right characteristic and right region to test the robotics companies as best as we can before we make an investment. The other thing we were able to do is take our historical project data and use the data to simulate the performance of the robot. For example, in the case of Canvas, where we also made an investment, we were able to simulate which projects where the drywall was on a critical path, and based on the inputs of the production rate ratio of the robot assumptions, how they can accelerate the delivery of those projects. So it's not just about the direct labor savings that comes from applying a robot, but the schedule savings on the back end of the project, if they can cause the project to progress along that critical path much faster. And each day of schedule savings can be really meaningful when we talk about projects that are $400 or $500 million in size.
Yeah. Alice, yeah.
Yeah, so adding on one more thing, I think oftentimes people overlook implementation. And that's actually something that we spend a lot of time looking at, especially since we've been on construction sites and we've kind of seen how difficult it is to implement some of these technologies in construction. So it's really the ease of implementation. And if you're thinking about, scaling one of these companies from job site to job site, and specifically talking about on-site robotics, how fast is it to set up? What additional technologies do you need? Whether or not you need total stations, laser trackers, do you need layout points? Do you need the floor to be clean? What kind of weather conditions? Can you operate in Boston where it's like so cold and, snowing? Whereas, I'm in San Francisco. So a lot of those companies are a little spoiled from that perspective. But yeah, like just looking at all the job site conditions and, can this piece of technology work in that condition? And we spent a lot of time trying to dig into that. And it's like, is it a 3-hour setup or is it a 5-minute setup? How easy is it to calibrate? At the end of the day, you're going to be training people on site to operate these things. So do you have a plan for, operations maintenance manuals and all that type of stuff? So we kind of focus on that because we know that the attention span of people who are implementing these things on site are very, very short. And if it doesn't work the first time, sometimes they'll never try it again, frankly. So you kind of have to like hit it where the iron is hot. And yeah, just making sure that that first implementation and customer success is really, really on point. So yeah, we love looking at, solving those problems on site and what are those, crazy huge TAMs that people are kind of just overlooking and we can bring in robotics for.
So one other point too is if you think about construction, it's always going to be like a race to the bottom in terms of pricing. It's the nature of the industry. And if you look at the majority of the market, that major chunky majority is not the DPRs and Suffolks, and it's a bunch of other folks that buy used equipment, right? It's a different market. So your R&D and your ability to innovate consistently and build new product, new feature sets, and drive down costs just as fast will allow you to actually get the market. When we see the same 5 logos of all the construction companies, we're like, of course they did. They're early adopters, they have budget, they have time, they have the intellectual capacity. Otherwise, you start looking at the major market, it has to plug in like a generator and turn it on, and it just has to work. And they don't care if it's computer vision or if it's anything. And that's why we've been really biased towards like, how do you build product, your R&D team? Are they building things that are highly defensible? Can they go toe to toe and really understand? And how do they have a plan to continue to add feature features and drive costs down, because it's the nature of our industry. You always want it cheaper.
Maybe that's a good test for something, is like, can you imagine this on the used equipment market? You know, what's somebody going to buy this secondhand? And then, you know, you probably have, you know, something that's got some staying power. You know, there's a lot of tech in this space. I mean, you know, we're at MassRobotics, we're surrounded by robots here, and, you know, all of the technical challenges that you know, listed. How, I don't hear much about business models, and how important is, when does the business model become important for the companies that you're looking at? Is that like, start talking about that right out of the gate, or is that something, you know, you kind of get to, you work your way into, or whatever?
Yeah, I can start with a quick thought. You guys should join me the mic.
I think for the streaming, you need it. Yeah.
Yeah. I would say the business model question is still an evolving question, because I think what's happening, there are two things. One is, a lot of the robotics companies are starting in our industry, they're starting out full stack, meaning they're a service provider using the robot, they become a subcontractor on the job site. The reason why they need to do that is they got to prove out the system before transitioning to a leasing model where they're selling the robot as a service, right? Which is where the VCs want them to get to, of course. But in iteration one, they got to go in and be on site with their own crew, and they have to guarantee some level of quality, right? The problems that come up with deployment, there's a lot of things to figure out. But there are a couple of companies in our portfolio that are now starting to think about the transition. Canvas is starting to think about that, right? How does this function as a venture backable kind of a robot as a service model? So that's, I would say that's one of the primary kind of questions we ask these companies that we talked to in robotics. The other thing is, what happens to the scope of work from a GC's perspective? Take layout, for example. You know, layouts are traditionally done by the different subcontractors, but if there's a layout robot that can take the model and do the layout simultaneously across all the trades and print the layout all in one go, the question then is, well, does scope need to be reevaluated and repackaged? Perhaps we may want to think about taking that scope and doing it on the GC level and coordinating the layout ourselves. So the business model question is actually really interesting, you know, and I think the future of our industry, we're going to increasingly start to see these robotics companies driving new business models, and the GCs and the subcontractors are able to evolve with that and maybe shift their own business model around the capability of these technologies. They're going to have a potential lead on the rest of the industry. And so that's something we're actively thinking about at Suffolk right now.
Yeah, I mean, we don't focus too much, because whatever business model a founder gives us, usually it's wrong. That's just the nature of the business. So we try to, in many cases, we actually think revenue is a distraction. It's a massive distraction. You're going to ramp up services people, you're going to ramp up process around quality and all of that. And in the meantime, you're not innovating your product. You're not working on building a great product. And so it's always cautious, right? Having people in the field using the product to deliver on something, to learn about it, absolutely. But there's also, I tell some of my startups, like, do it for free, because then you'll never get addicted to this cash flow from services, this revenue thing that starts coming in, that in early days can be a massive, massive distraction. So a lot of times we get very contrary about, like, well, they'll pay us. And I'm like, don't take the money, do it for free. One, you'll be a lot more efficient about how you approach it. You'll be better at it. And you're not setting a precedent culturally within your company, because running a services company, it's the worst thing ever. It's the worst thing ever. But the cash is good. So as a starving startup, the cash might seem remarkable and the place to go, and you chase the cash, but it's rare that a company ever makes it.
There's one piece I wanted to add. You know, I imagine other verticals have been sitting here. You've had probably an automotive and robotics session, and logistics.
Not me, but,
Don't look at the logos. But for anyone who's attended those other sessions and comparing this, the construction industry doesn't have R&D. Okay, sure, there may be one or two very large companies or a technology provider, like my former employer Hilti invests $400 million a year in R&D. So those technology providers, yes. However, the end users on the building are not going to sit around and fund an R&D effort or even allocate people or time to it. So I think that is one difference, that going to an Amazon or a Prologis in logistics, or going to one of the big 6 automotive groups, you're tapping into very large pools of R&D, not to mention government research funding, which is quite large. And so I do think it is very important, given the number of stakeholders on a typical job site. It can be 40 firms working on the same job site. So who is going to then pay? Is it going to be the owner, the GC, the subcontractor, the technology provider that's selling to the subcontractor? And at least while that model keeps pivoting and may change a lot over the course of a funding stage, at least to have a hypothesis and come in, meet with us as the VCs and say, this is our hypothesis. It may be wrong, it may be a little this direction or this direction, but we do like to hear that nuanced understanding that this industry won't fund R&D. Time is very short. They want to purchase a completed product. And so what is your positioning against that multi-level stakeholder, I think is really important.
And grant money is fantastic. Get your grant money. There's a lot of grant money out there. I've seen companies, one of my companies that actually used to be up here, we got $15 million in grant money before we hired our first employee. It's fantastic, non-dilutive. You had to give a quarterly report, which was like 3 slides. It was fantastic. It's a lot, much better than venture capital. Ours actually came from Walmart's foundation. We had a company called Software Automation that did apparel.
Interesting.
We've done government too. We've got money through DoD as well.
So
Alice.
100% agree on non-dilutive funding. We have Branch Technology, one of our portfolio companies, was able to take advantage of AFWorks, and there's a couple of other government-related opportunities there. But I did want to touch on the services model. So we actually believe that for robotics and hardware companies, it does actually make sense to be a service provider at the beginning. And a lot of it has to do with just being on the construction site, being able to work with the conditions out there and being able to iterate very, very quickly and continue to develop the hardware and the software side, and have access to the customers at the early days before you kind of have this, perfect product that a Hilti might acquire or something like that. So we actually believe that, hey, it's great that you are a service provider and you're getting revenue while you're doing it. So it's also great to kind of reinvest that back into the company as you're continuing to grow. And you're also proving value, right? If it's a valuable service that you're providing, people are willing to pay. And I think it kind of just validates the position in the market. And for the most part, if you're adding value to a construction site, whether it's schedule savings, you may even be more expensive than, like for layout. It is more expensive to hire one of these robotics companies, but the schedule savings is just so big, like you mentioned, Wanley. Right? Exactly, and the reduction of rework that it really helps solidify the value for that startup. And they will eventually get to a point where it's like, okay, let's start doing the leasing model. So Canvas operated as a subcontractor for these large GCs and subcontractors as a sub-tier sub. For probably, I think, like 2 years or something like that before. And now they're starting to offer that partnership program where they're training GCs and subs on how to utilize that machine. And now they're leasing the model. So I think there is a valid point. And depending on what the product is, right? If it's a simpler scope of work, maybe you don't need to do that services. But I think it's always good to just get the roboticists out onto the construction sites to understand, like, there's a giant hole. Like, how do I deal with that? I don't know. Like, this wasn't shown in BIM. Like, what do you do? So I think it's the real world conditions that really help, make sure you have a lot of those edge cases covered out on site.
Interesting. Yeah. Contrasting points of view for sure. I'm thinking about, directed engineering is kind of the, when a startup starts headed towards like doing engineering specifically for one particular customer, sometimes that's a little hard to sort of get out of. Do any of you have examples of where, somebody who started out, demonstrating their technology on a service basis was able to sort of punch through and become as a service provider or, at least a franchisor of their service?
I think Revit was a service provider at first.
I was a little different, but yeah.
I think it was
No,
before they sold. I think part of the challenge was no one knew how to use it.
Oh, it was a subscription model. Yeah, so it was that, but they didn't do the design work, right? They weren't the contractor or subcontractor.
I think not necessarily like a franchisor, but I know for Canvas as an example, and I know we keep going back to Canvas, but a lot of it has to do with just them being probably the eldest in construction tech. I mean, they're the latest stage out of all the ones that we're seeing. And they're now working with WebCore and DPR and Swinnerton, and there might be one or two others that I apologize for not mentioning, Suffolk as well, doing the training, but not necessarily franchising, I don't think. Like, you guys wouldn't help operate that for other folks or other competing companies, I'm assuming. I don't know. I'm looking at you because you might know more
Not
than
right
me,
now.
but yeah, not right now. Yeah.
Rick, I think it's probably early. I
It's
think
early.
it's early. I will say I think we track, and this is to the startup founders. This is not an industry where you have to be worried about first to market. It's probably better to be a fast follower, right? Follow these companies that are doing different things. If they're not investing appropriately in R&D, you should be able to leapfrog them. We have a couple of companies that we say, oh, they're just like Procore, but cheaper. That is an okay value proposition. I mean, it really is. And I think when it comes to robotics, it's okay. We don't get too caught up on like, oh, well, someone's already doing that. Like, I don't think that's important. I think it's okay. It's probably better that somebody's already doing it. Let them go burn through a bunch of cash, learn from their lessons, poach their people, keep moving.
I was going to say, I think Autodesk has done a nice job showcasing at AU some of the traditional manufacturing makers who have made their machinery more mobile. And sometimes I often prefer the term software-enabled machines to not overly hype the ability to do a lot of autonomy applications. But I was thinking, for example, FrameCAD from New Zealand and machinery and getting further and further closer into the job site and enabling more degrees of freedom to do customized work. I think is a very fascinating application that keeps advancing. And some of those teams then are, of course, selling machines or partnering pretty closely as well with the subcontractors using them.
So Alice, you were talking about, one way that the becoming a service provider is a way of sort of validating their technology on a construction site, finding somebody. Suffolk, you bring, I guess you have people actually trying out their technology on your sites. I mean, you're, right there, you're a laboratory for them. What are some other ways for, maybe startups that aren't in either of those modes? How do they find those pilot customers, or how do they get somebody to let them run a robot around on their construction site?
Well, some of the testing we do is with our subcontractors, right? Because as a GC, we've got over 10,000 subcontractor relationships across the country, and so we're able to identify, like with Canvas, we got them with Daly's Drywall out in San Francisco pretty early on during our Boost program, and so we're able to kind of figure out what job, what region, because regional differences in construction is pretty big, right? Even the materials that are used, labor dynamics are different, union, non-union, some of the things we mentioned earlier. And so again, being able to figure out where a company can go and sort of match with the early adopter characteristics in the network, we're very sensitive to that. So we have a partnership program where we help companies find their way to the right first application, first use case. And as I mentioned earlier, we can even test some of their assumptions using our historical data. So we're one of the few construction company, we've invested about 4 years and a lot of money in building a clean data lake. So we're aggregating different construction management software systems, our own schedule systems, our cost information. And so we're able to create a data platform for startups to kind of test certain assumptions on. And that's something that, founders have found to be pretty useful. The last thing I'll say is that we're looking to open up a small innovation center. So I've taken a lot of inspiration from your work, Rick. To create a space where our experts from Suffolk can cross-pollinate with founders from other industries that bring technical skill sets, robotic skill sets, software, but are looking to partner and gain expertise from our industry, because it is a pretty difficult industry to navigate, right? We talked about business model, the industry structure is fragmented, the stakeholders are not always aligned. It creates difficult conditions sometimes for innovators, entrepreneurs to navigate. And so we want to make sure that we can bring the right resources and reduce that friction. And that's one of the reasons we're thinking about venture creation, innovation center, all the good stuff you've seen here. We're looking to do that specific to construction.
I think in terms of getting started, I'm a big fan of like academic associate, like go work with someone at a university. There's a lot of space, there's a lot of resources, there's a lot of talent, highly intellectual, curious groups of people. I personally do a lot with Georgia Tech in Atlanta, but there's space, there's opportunities. As you're trying to build your startup, it's a recruiting ground. It's also, if you're going to someone that you want to demo it to, like, oh, my lab's down at XYZ University, that goes a long way. There's a lot of resources, and you know, my view of like robotics or anything truly, it takes time, right? It takes a lot of time. It's not one of these things you go raise 10 million bucks and you build it overnight. It takes a lot more time, and I think people underestimate the opportunities, and especially in the building construction department and architecture department, civil engineering department, they have lots of lab space, and they're thrilled about anyone innovative wanting to come do something on their property, in their lab. So I would definitely never underlook kind of what's happening at universities. They're a great opportunity.
All right.
I would say this is where it may actually be worth looking at the like top tier innovative contractors, because a lot of the times, they do have a bit more budget and man hours to spend on testing out this new tech. I have connections like, my old DPR friends, right? I have a guy named Henning who is leading construction robotics. And for a lot of the startups that I talk to, it's like, hey, like talk to Henning, like he would love to pilot this. So I think that's where like looking at, the types of contractors out there, reading the media, understanding like who has an appetite to pilot, it'd be great. And there are mechanical contractors out there as well. Like here in Boston or near Boston is EM Duggan. They have one of the most tech savvy mechanical prefab shops, and they love testing out new tech. So I think it's just finding some of those contractors in industry and being open to reaching out to them. Feel free to reach out to your investors or people that like a lot of the times, like we're all connected and they're all connected with kind of a lot of the innovative folks. And I think they're more than happy to test out or share feedback or whatnot. But really it's networking with the AEC space and understanding who within those organizations may be the best point of contact. And that in itself may actually be pretty complicated. But once you can get the right person, chances are they're going to be excited about testing out any type of construction robotics.
Yeah, I'd second that. I mean, part of it is this reason I spend time in this industry. It's like salt of the earth people. Like in the AC space, it's just fantastic human beings in most cases. There's a few rogue people, but generally, right? They're happy to take your call. They're happy to meet you with coffee. I mean, they're super, super nice people, and I think they all believe that there is a mission that we can do it better. I don't think anyone's sitting in their office going, man, we did this great, we're the best. I think they're all kind of feel that weight on their shoulders, and they're more than happy to talk to you. I mean, just great people in the industry.
All right. Well, maybe we're getting towards the end of the time that we have available. Maybe we end with like one quick speed round, right? A tweet from each of you that you would, not really a tweet, but in a few words, what is it that, what do you think would be important for this audience to think about? Think about the, startups in this space.
I'll just maybe give a quick stat. I just saw this a couple of days ago, but there was some stat that I saw that said that this year we're going to be short 600,000 workers in construction. We have a critical labor shortage issue. So automation is not an option. It is actually needed for us, the construction industry, to function going forward.
Great message.
I would echo that. I would say this is inning 2. So call friends working in other industries in automotive and logistics and tell them about the opportunity. What is more expensive than our house or our office space or our highways that are practically collapsing? So please come into this industry. I think we have a ton of opportunities and applications across the building space. So there's a lot of opportunities to be had, and it's still very early on. I think we could count on our hands the number of major success cases so far. So there's a lot of unicorns to be made.
Yeah, it's early innings. I mean, they talked about one company 4 times. Yeah. so it's not crowded, right? Look, I think generally we love to see a technical co-founder. I don't think you're going to build a robotics company without 2 technical. I mean, you don't need a CEO. You need 2 CTOs that understand what they're doing, kind of thing. So in this space specifically, like just get a technical. You can't outsource this stuff. You can't partner on it. You have to have strong technical bones in a mindset. And like I said, we hate to see like company. We won't invest in a company without a technical co-founder. In a robotics, I don't think there's even a question about it.
I'm most excited about kind of that link between the digital and the physical world. So I spent a lot of time with BIM and VDC and coordinated models and all that type of stuff. But I'm excited that we can actually take that digital data, bring it into the field and reduce rework. So that's my thing is like, digital to physical, and then now the opportunity to kind of close that feedback loop and bringing in field data back into the digital side so we can have this way healthier kind of feedback loop in like the whole life cycle of some type of building.
All right. You and I had a quick conversation before this I thought was actually pretty interesting, and that was, how cloud and mobile computing gave an opportunity to bring the data out into the field, get that into the field. And it feels like mobile and autonomous robotics are an opportunity to actually bring, to affect physical work in the field in the same way. And just as now, cloud and mobile devices have become ubiquitous, 10 or 15 years from now, we'll probably find autonomous and mobile robotics ubiquitous on the field. Thank you all. This has been terrific. We're going to be hearing, we have the program now is taking a short break, as we can see from the slide. And then we're going to be hearing from some startups. I'm looking forward to that.
5 minutes break, and then we resume for the second half. Very good. stop checking emails and be in the moment. Seize the moment. Okay, what an amazing panel. Do you agree? I really love the diversity I have seen on the panel, different backgrounds, different approaches, different perspectives. Amazing, Joyce and Rick. Amazing job putting this panel together. Well done, well done. So now, moving to the second half, it's my pleasure to introduce Peter Biladi. I hope I'm saying the last Biladi. And Peter comes from Danfoss, and he's actually leading all of the autonomous vehicles at Danfoss. We kind of started chatting last summer, and I had no idea why Danfoss is interested to become a partner of MassRobotics. And then he enlightened me and said, Ferry, we have a special program that I'm leading, just focusing on autonomous vehicles, on the off-road vehicles. So Peter will speak a little bit about that. So I'll give him the floor, and after Peter, we'll start listening to the amazing, innovative startups. So Peter, floor is yours. Give him a round of applause.
So thank you, Fadi. And as he said, my name is Peter Blade. I'm the head of autonomous vehicles for Danfoss Power Solutions. Danfoss is a company that most people don't know, but it's probably a company that you've run into in your everyday life, and especially in the construction industry. Danfoss is the largest hydraulics and electronics supplier in the off-highway industry to off-highway vehicles. So that includes construction, agriculture, material handling, ground support, etc. Danfoss, from the climate perspective, is very large in the heating and cooling. So everything from the heating and cooling units that would function in this building, all the way down to a residential size, all the way up to the district heating size, where you're running an entire district heating grid to heat or cool a city. And finally, on the drive side, significant amount of power electronics business, focusing on renewable energy, but also focusing on factories and things like that. So really across the industry, whether it be in manufacturing, whether it be in mobile vehicles, from excavators and wheel loaders all the way into the agriculture space, or in heating and cooling units, you've probably bumped into Danfoss at least at some point in your life. When we jump in, when why, autonomous vehicles, why Danfoss? When we look at our power solutions business, what you really see is we provide all of the components that go into a vehicle. And so when we talk about construction, what I would say is, I really don't know anything about construction. I see the construction space through the lens of the vehicles that operate in construction, through the lens of what an excavator needs to do. A large utility vehicle like an excavator, a wheel loader, or skid steer, like you see on the construction site right behind us as we walked in, all the way down to the very specific equipment that maybe a Vermeer or a Elgin might make, that might operate very specifically doing one job on a construction site versus a utility job. And so we will work with those companies to optimize their vehicle for either how utility or how specific that functionality is. And when we talk about the autonomy side, my team will work on the software side to not just integrate all the hardware parts that you need to develop that vehicle, but also to integrate all the software, or for the full software integration, not just at the control system level, but also at the kind of decision layer and the perception layer and all of that functionality as you go through. So who are our customers? Just from the Danfoss perspective, within the construction industry, probably a lot of names that you recognize up there: Caterpillar, JCB, John Deere Construction, Palfinger, Case New Holland, all the way through to Sany, XCMG, etc. In addition, when we look at what industries we serve, we not only just serve the construction industry, but also specialty agriculture, row crop agriculture, material handling, and road building, etc. And so one of the interesting things is that we get to see the problems that address those different industries across those different industries, and see and kind of learn a little bit about each industry. And every industry has a labor shortage right now, and every industry has a lack of skilled labor. But one thing that we've seen is it's significantly worse in construction. The construction industry has a continuing to age, average age of a worker. In the US, I think the statistic was shown, 600,000 construction workers short. In Europe, it's over 1 million. And the current conflicts and things like that are not helping to drive that statistic any better. And so a lot of the things, not only is there a lack of labor, but you're also having younger and younger labor that comes in with no experience. And the reason that becomes more and more of a problem is that we're seeing, especially related to the machines, is the machine has become significantly more complex to operate. So you can see on the left here, in 1989, the machine had 2 pedals, a clutch, a steering wheel, and a little bit of operations to move hydraulics. This is a wheel loader cab to move the bucket up and down. And you look at the current kind of state-of-the-art machine today, there's no longer a steering wheel in a lot of these machines. It's up to a joystick. There's multiple displays, multiple human-machine interfaces, and overall, the operation of that machine is no longer something that you can step in and say, okay, I know how to operate my car, and probably about a day or two, I can start to learn to operate this machine, right? The complexity of the machine's gotten higher. And what that's really causing is safety issues, rework, lack of productivity, and it's really driving problems in that area. So how do we start to solve for that when we talk about robotics, when we talk about autonomy, and kind of the vision and the lens that we see that through? And really the answer is increase the safety, increase the productivity, and increase the precision. And move that safety, productivity, and precision onto the machine itself. And that doesn't need to be an off-highway machine. That can be any machine, and in the 6 startups that are about to go next. I guarantee you each one of them has some precision or higher quality functionality that's pushed onto the robot, or some productivity that's pushed onto the robot, or a more safe solution that's pushed onto the robot, or a combination of any of those things. And what I mean by that is, when we've worked with a customer specifically around safety with an OEM, we worked with an OEM that had a customer that was paying up to $20,000 in insurance per year for each member on the job site, because of the number of safety incidents that that person had had on their job sites in previous years. Working with the OEM in that case, adding something simple like collision warning, collision avoidance onto the system reduced that insurance cost greatly. There's significant value there in insurance. When we talk about productivity, 30–40% gains in productivity are easy to grab as you start to automate functionality and automate certain things around a job site. And it doesn't need to be the big fancy thing. I mean, it's you spoke about Built Robotics, and a lot of what they do is that increasing the productivity of the boring thing, right? Trenching is not the most exciting thing, but it's something you might have to do for 5, 6, 7 hours, especially on some sites. Road building, not the fanciest thing. It's repetitive and continuous. But if you can increase that productivity and not lose any of the precision, or even increase the precision and reduce the rework, you can drive that through robotics itself. Lastly, as we move forward, the industry is just starting what we see to adopt today. And so I found this fun picture of what looks like Star Wars robots or something along those lines on a construction site. But as we start to add more and more intelligence on the machine, we mentioned it earlier that you're really in the first inning right now of or first or second inning, right? We're still in that horseless carriage days. So what does a self-propelled or autonomous soil compactor look like? It looks like a soil compactor, but that doesn't mean that that's where it's going to stop, right? It's very early days and moving on. And as you move forward, we see that kind of vision driving toward the future. So lastly, as kind of to introduce the 6 startups, one of the things that we see, and what at Danfoss we're interested in not just working with our OEMs on, but in the technology space, is seeing technologies that drive that safety, productivity, and precision, as well as starting to move those years of experience, that lack of experience, move that experience onto the machine to drive experience overall. So hopefully I've caught us up a little bit on time, and back to you.
Peter, thank you very much. This
in there. Here's an example use case learned from our construction partners. So after buying an existing building, it's necessary to map and inspect the structure to plan improvements and identify deficiencies. A camera can be used to visually map and inspect all the nooks and crannies, and even identify things like pipes and cables missing from existing plans. The data collected can then be integrated into a building information modeling, or BIM system, all without disturbing the occupants and without damaging the structure. That's the power of the FlexBot. The FlexBot can allow for next generation energy retrofits, like spraying foam where installations collapsed. How about spraying that foam in the wall, or even caulking windows without the need for scaffolding or high-lows? And then, the uses for the FlexBot extend beyond the walls of our physical structure to the utility infrastructure connecting us. A worker can remain safely on the ground while operating the FlexBot, avoiding the works and the dangers of working at heights. And here at Flex Solutions, we're offering cutting-edge robotics at power tool prices, which allows them to actually mass deploy across your entire fleet. And then, since every FlexBot link is identical, users can combine multiple links as needed for a specific job. We're starting here in these multi-trillion-dollar industries like construction, utilities, and public infrastructure. But what we've really honed in on as our launch market is this last meter of inspecting in the scan to BIM. There's those technologies that can get you the floor print, but what about above the ceiling, under the floor, places like that? And then we can expand from there. We've also partnered with Gensler, the world's largest architecture firm, and Skyline Capital Builders to form Team FGS. We are phase 1 winner in the Department of Energy's $200,000 e-robot prize for minimally invasive building envelope retrofit technologies. And we're currently in the middle of phase 2. We'll find out April 7th if you all tune in to see if we win phase 2 of that e-robot competition. Last year was also a good year for us in terms of awards. We won Most Fundable Companies from Pepperdine University, participating in programs like Plug and Play Ventures, Construction Real Estate, and then to form partnerships with folks like Hover and also like Creative Destruction Labs out of Toronto. Here's our roadmap as a company going forward. So right now this year, we're excited about soon starting off demos and pilots with major construction partners towards a fundraise and really starting to get these units. Next year is really developing the hardware and software at that scalable size towards off-the-shelf turnkey solutions in 2024. And then what we really see as the future opportunities is self-driving. Our ability to extend and rotate allows us to climb through walls and navigate, but again, that's a data-driven thing that can happen down the road. And speaking of data, mass-deployed FlexBots allows the opportunity to collect that massive amount of data needed for these things, but also look at data-driven insights. So our team here has worked at leading organizations before joining, but we're really passionate about mass-deployable robotic solutions. And we're hiring a head of software and autonomy, so if that's you or anybody you know, please send them our way. Thanks again for the time. It's an honor to join such an esteemed panel and be here today, and look forward to connecting on and offline.
This was amazing, man. Thank you very much. Next, we have German Bionic Systems, David Mack, Managing Director, North America.
Thanks. You guys don't have to clap, it's okay.
Thank you.
Now we gotta clap. I mean, you could. If you so, really great talk so far today, and a couple of points that I've thought about. First off, there was so much talk around automation and around taking the worker out of the workplace. We also had conversations around an aging workforce. We also had conversations about how the workforce we need, what was it, 600,000 new construction workers here in the US, 1 million in EU. So basically a lot of those areas within construction sites are still going to need people, and they need people to work safely, they need people to work productively. And so the approach that we're actually taking from this is the development of the Gregg X. We're a German company. We've done Series A funding and just introducing here in North America for lift assist and walk assist of the person. We actually utilize robotics on each side. I have actually a demo of this later. What's that?
Have to reestablish the connection.
Oh, do we? Okay. Yeah. Should I pause or continue?
Yeah, pause really quick.
All right. Anyone know a good joke? I can keep talking just for the sake of time. Basically, we're providing lift assist from the lower back standpoint and also walk assist from the upper legs for both walking and climbing. There are a couple different motions that you do when you're lifting. We all know this. You're lifting down, lifting from something from ground floor, putting it up to waist height, taking something from waist height, putting it back down to ground floor. Our actual solution provides benefit for all of those areas, along with the static work case of actually when you're in a bending over situation and having to sit there in a bent over situation for a longer period of time to, again, relieve pressure, relieve stress off the lower back. Here's another, whoops. And it's actually, oh, there we go. Within a construction site, lifting bags off of a pallet. Again, that repetitive motion, that repetitive lifting of weights and putting them in a different area, and we're actually benefiting the worker from that standpoint. What's also interesting about the Cray, and really I think this is going to hit home for a lot of people, we're actually connected. And so not only is the Cray actually providing lift assist from a robotic and from a battery source, but actually all of that data from the actual device is then being sent over Wi-Fi, over LTE, into dashboarding, where you're actually able to track and monitor the utilization of the actual product as well. You're able to monitor the number of steps. You can actually 3D map the lifting and the actual motion of the individual. So then in the future, and we're actually working on this right now, we can tell when workers are getting tired. We can tell if they're lifting properly, if they're twisting too much. We can actually determine the actual state of that worker to make sure that they're being safe and they're working safely within their environment. Each Cray also is self-learning, so the more you use it, the more an individual actually wears it and lifts with it. It actually does start to understand that individual's lifting motion and how they're actually moving, and will actually start to feel better and actually provide more assistance further on as we're moving forward. So as it says here, multiple workers, when you first put on the device, you actually enter in your individualized PIN number for that device, so then you don't need to use that same one. You can use multiple devices with the same PIN number, and then it actually understands and recognizes your settings, and you can use it immediately. Just a picture of the dashboards that we have. These are actually available right now. You're able to go online and again see all of the information that the workers are using, the amount of lifting support, and even if you see there on the bottom, a little bit of gamification after you're done your session shows you exactly how much you've lifted, and in this case, this person lifted the equivalent of a cow. So a little bit of gamification there as well. You see that little cow there on the bottom. I think there's a cow, there's a motorcycle, we have a house, a few other things. A carton of milk, yeah, sort of 8,000 carton of milk or whatever it is. The overall device, this is my last slide here. I see Joyce standing up, so I'm assuming. No, I have tons more time. Excellent. All right. I'm going to go through each one of these points really slowly then. So really from a device standpoint, it weighs about 15 pounds, but it actually sits around your hip. And again, very happy to show you, very happy to try it on afterwards. So it just feels like a backpack. And so once you put it on, it actually you have full range of motion. You're able to move around with it just like normal. Carbon fiber, it is able to lift assist for you up to 66 pounds, which is a significant amount. And at that point, you're actually at really your leg or your arms, your wrists, those are becoming the weak points. So you're really taking the back out of the equation from your lifting and from your lifting posture to be able to support that and really protect the individual. As mentioned, we are completely connected to Wi-Fi, LTE networks, so over-the-air data transfer. We provide updates to the software, just like the tiredness indicator that we're working on right now. That'll actually get deployed on all systems in the field through the on-air update or over-the-air update, and that should be available in about 2 months. And also it's IP54 compliant for dust and water as well. So really, I mean, very excited to show this, very excited to actually introduce this into the North American market. We're actively growing our team over here, and really, if anyone wants to see the device after the presentations, I'll be sticking around. I'm very happy for anyone to try it on and test it out. So again, thank you very much for your time today, and I appreciate it. All right.
Thank you very much, David, and we do apologize for we lost the connection for a minute. Now, David Askey, founder and CEO of Robotics.
Okay, thanks. Okay, good for the next one. There we go. Hello, David Askey. Thanks to the panel for a great discussion earlier. Thanks to Reddy for setting this up. It's good to see some of the new work that Danfoss is doing. So, I'll let you start that. So, Robotics, so we started just about 4 years ago, basically a team of MIT alums that had done a lot of work for NASA and DoD, solving hard robotics problems for them, combined with operations team with deep construction industry expertise. You know these projects for DoD maybe from before presentations. We can go into those separately, but let me get on to the construction core. So our focus is on the commercial construction, precision spraying, precision mobile autonomous spraying. During COVID, that market sort of went to almost nothing for a little while. So we pivoted to where we're getting pulled, which is doing more spaces like warehouses and planes and ships. Just for reference, this one ship has more paintable surface area than that whole hospital complex that's shown. We didn't know that beforehand. That's a lot of paint and got our attention. This is the sort of job that guys do right now in this space. It certainly is dirty, dangerous, and not fun. Project we were on a few months ago, one of the painters texted me halfway through the first day with himself covered in paint and said, "Can I drive your robot yet?" So we're building them. Let's see. Joyce is set up for the next.
Yeah.
Maybe move the cursor up. There you go.
I just need to get to the next slide there.
Sure. There you go.
Okay. So we have for interior, for doing construction jobs, we have a mobile robot that navigates the space, finds walls, goes along the walls autonomously. We call it semi-autonomous because it's asking an operator for clues at first, as it learning the space, learning what to paint, what not to paint. And then as it learns more about the space, typically in a small number of rooms or even in the first room, then it gets to be essentially fully autonomous for that. But it will ask for clues from an operator as it needs help. Started out with reach of 10 feet high, did our own manipulator because there was nothing else on the market that would give us a 10-foot reach with, we have 2mm precision, and we needed something to shoulder carryable so we could get it up and down stairs and into any construction location. We got a call. We had been looking at the industrial space. We got a call that a ship that was supposed to go into Mobile, Alabama for repair was damaged and had to come into the nearest port, which was Dry Dock, Boston, which is 10 minutes from here. Said, "Can you guys help paint it?" This was the middle of COVID, and they had trouble getting enough folks on here. That step turned out the crew. Can I pause this? Oops. So turned out the crane crew was out with COVID the first day of painting, so we had to carry the bot down 40 feet of stairs. So turned out it was good that we had spent time making it modular. This is sort of the site. We're operating the ground. Alice, you said, work in practical situations. It's snow and maybe 3 inches of mud when it wasn't snow. The bot had to navigate in. In just a second, we'll show the bot in action. So we went from indoor bot to outdoor capable bot that can work at sub-freezing temperature and be mountable on a boom lift and some retrofit of the boom lift in 7.5 weeks. This is the bot spraying. I'll show it starts slow at first as it's mapping the surface, learning the curved surface and painting it. And then it speeds up as it learns. And so for this, started out very slow, and by 90 minutes in of learning, it was painting at about the speed of a 3 or 4 person crew. And precision of this, manual crew had paint thickness about plus or minus 27%, and lost several days of painting due to rework. We needed a strip paint that was put on just a little bit too thick. Our bot needed 0 rework, and we had inspectors there every day testing the thickness. We were plus or minus 10% over the whole project. And we're glad to tell you more about where we're at for construction robotics in a range of environments after it. Thanks, everyone.
Next, we have Brent Wallace. He's the CEO of Build.
All right, thank you. Well, thank everyone for having us out today. I'm excited to be here. I'm also excited because there's a lot of amazing companies here. I think I need to buy one of your things for stairs. And then I'm painting my house later, so if you guys accept MasterCard, good, we are in business. So we're Bot Build. Build homes with robots. It's pretty straightforward, but what we do is we use a software-based system to allow our robots to flexibly move to any design necessary, quickly and efficiently, panelize the home, put it onto the job site, and we take away the necessary delays that current framing has. I could hammer home how many jobs we are short currently, but this crowd understands that pain. Basically what we're doing is we're using the precision that robotics allows us and putting in place, using our software system, a way to redesign and rethink the way we use automation. So the market that we exist in is obviously huge. And the reason that we are here is because of the labor shortage. The reason automation exists, one, you kind of stole my line here, automation is no longer an option. It is the necessary for our future. We are short 600-something thousand this year alone. It's a 3 million total shortage if you look at construction as the aggregate. And we're looking in America alone at a 5.5 million housing unit deficit. That only grows year over year as we're currently not building enough to meet demand. So how do we do what we do? Well, as I stated before, we, instead of starting with a hardware solution, decided to start with the software. And so what we do is we take in any type of plan, PDF, 3D design, CAD model, whatever. We take that in, we scan it into our system, and it from there does a couple of things. I'm oversimplifying this a bit, but essentially, it first creates what we call a panel book using our system that we've creatively called the Panelizer. I know, our marketing department is incredible. When we have this panel book put together, a builder or a developer or a GC can look and see exactly what his blueprint or her blueprint turned into in panels that are easily put together on the job site. It also puts together instructions for the job site. Currently for residential homes, for single family, that is a one-page document. And it shows exactly where every panel goes, 1 through N, let's just call it 70, so that the workers on the actual job site can put it together. So our robots then, after having the panel book put together, and we get told the A-OK after a couple of hours of hard robot work, they're told, okay, now build the thing. And from there, it turns to the scheduler, and it actually turns that into robotic code where the robots choose for themselves the most efficient path. Now you notice in this picture here, now we've finally gotten a lot of our patents in, so I can actually show a little bit more on this slide depicts. We're using off-the-shelf robotics. We're using basic FANUC R2000 165s. What we do instead is we 3D print our own tooling systems, which allows our robots to do different type of tasks at different times, moving quickly and efficiently throughout the build process. The third picture there is after we've shipped the panels to the job site. Right now we're in the iteration where we are just simply shipping out the panels to the job site. You can see they're in 4 neat little stacks. That's about an 1,800 square foot home. That is one of our first homes done in Bentonville, Arkansas. And the crew, instead of taking this particular builder, one of our early pilot programs, this particular builder was telling us they take anywhere from 5 to 17 days to frame a house. They did our first home in 5.5 hours. And now on home number 5, I believe the record is 2.5 hours to actually have the home framed, which is not only, as I'm sure we all know, the metrics are there, it's not just about time saved, it's about money saved, it's about the efficiencies that come after that. And from the client perspective, that builder being able to point to the client and say, we're doing stuff, I promise, there's a home there now, and now you can blame everything else on the bureaucrats doing the inspection. So essentially what we do here is we make it faster. We are faster than traditional builders, obviously. Waste generation, though, is a real topic, and thanks to lumber just deciding to do whatever it wants to do in the open market right now, we are able to look at real waste savings as a real cost benefit to the builder. Using robotic precision means we know exactly where our cuts are, we know exactly what they need to be, and we know exactly how the lumber needs to be used and optimized. And less lumber means less waste means less money coming out of your pocket. And for a large-scale builder, that adds up to tens of millions of dollars per small development. So we like to think of ourselves as kind of the next generation of robotics. We've started with software. We're using basic off-the-shelf robots, but we're using very advanced printing technology for our tooling systems. And these tooling systems are what allow our robots to act flexibly, based on whatever the software is telling them to do. So rather than spending tens of millions of dollars on huge amounts of automated lines, we're spending a minimal amount leasing our robotic systems and just able to use our tooling systems, taking in any plan at any moment. You can ship us one plan one day and say, actually, I'm feeling peckish, do this one next. And the robots will just shift to that plan because the software enables it, giving us the flexibility that I believe modern design needs. And so, our 4 key factors here. Basically, the flexibility of any design at any time is what allows us to meet the market where it is, not just tell the market how they should build. Everyone in here that deals with construction knows that you don't culturally just tell construction what to do. You listen to the market, you work with the client, and you move forward. Our factories are a fraction of what most automation and construction factories cost, which is a huge benefit, obviously. We are the first to market with this flexibility system that is based on our software system. And we've got an award-winning team. I was shocked to hear from KP that there are founders that don't have technical co-founders in their teamwork. We have an amazing team that works together. I spent years working in special operations, which is the honor of a lifetime, by the way. If you're in uniform, holy cow, I got paid to jump out of planes, race fast cars, and go take down bad people. It was the best time of my life. But doing that meant that I learned a thing or two about what it meant to have the right team, the right culture for the right level of success. And this is the team we've put together to understand the culture of building. Most importantly, it's the team that has helped us understand how to take robotics into that culture so that we can bring robotic precision into every home in the world. So that is bot built, and I'll see you two gentlemen afterwards for the Visa or MasterCard.
Thank you. This was amazing. Next, we have Omar Narayan. He's the CEO of Clay Robotics.
Thank you, Reddy. Thank you to MassRobotics for MassRobotics is always throwing these amazing events, so thank you. All right. So my name is Omar Narayan. I'm the founder and CEO at Clay Robotics. What you see there is our amazing little drone, which is what we think is next generation drone technology. But we don't see ourselves as a drone company. We're actually a data capture company. And thanks to all the other startups that really hammered the point of lack of employees and the Great Resign. So I don't have to do a lot of work here, but basically what we do is help construction companies and other types of companies capture data and use that data to streamline processes so you don't have to do reworks, and also you don't have to rely on the workforce to capture that data. So there's a big capability gap in terms of the type of data or data capture in difficult to reach areas. You have other types of robots that normally work well in confined spaces. So we saw the arm that goes into some really tight spaces. So pretty cool solution. But you don't have other types of robots that can get into those crawl spaces or operate safely around people or reach into high areas, especially without having a human carry something. So that's where we come in. Our technology, which we call the drone, I'm going to play this video here. It kind of shows you what it does, and I'll talk through it as well. Does this work, Joyce? Mm-hmm. All right, good. Okay, so, all right, so that was actually shot right here in this room. And what you're seeing there is how agile the platform is. We can do a demo afterwards. And the idea is that it's super small, super compact, super safe. So the next section here, you'll see it flying around a person. So it's super safe to be flown around people. So you don't have to disrupt your workflows to collect some type of data. We also have some cutting edge sensing on board. You'll see here flying through more of a relevant type of environment through some piping. Like that area there is only about a foot in height. And here we're going to cut into the LiDAR footage that is being collected in real time on board the drone. So we're able to do some type of 3D reconstructions. Super easy to fly today. We're hoping for full autonomy in the near future. But that's it, flying through very relevant environment to construction sites. And it's safe around equipment as well. So you can see here bumping into some type of equipment, no issues there at all. All right. So how do we get back? Joyce?
It should be a PowerPoint icon on the bottom.
All right, so I'm not going to bore you too much with technology, but basically, technology for this has been around for about 70 years, or the concept of it. Nobody's been able to commercialize this technology for various reasons. So we're the first company in the world to actually commercialize this technology. It's patented, and we just launched recently. When we have our list of customers is growing. from companies like SpaceX, General Motors, Chevron, and the list is growing. So what we envision this technology to be used in construction for, well, today it's sort of getting to those tough to reach areas to do some sort of inspection before demolition, seeing things that otherwise would be really difficult to see. But we're working on a fully autonomous solution where this drone can live on site for progress tracking, producing BIMs, that sort of thing. So we'd love to work with any construction companies and sort of develop this technology and get some feedback on what we have today. We think you'd find it very useful. Thank you.
Thank you, Omar. Next, we have Jeremy Searock. He's the president and CTO of Advanced Construction Robotics.
Well, good afternoon, everybody. Thank you for the applause. I'm certainly excited. We've been doing construction robots now for 5 years, so really excited to see other companies in the market, more VCs in the market, and I think it's an exciting future. A couple of things I noticed in hearing these speeches that I full-heartedly agree with is this idea of, we are building robots now to fit current operations of construction, to sort of ease the way in which we get into the industry. But the real change for the industry will be when we're able to adapt the designs and be able to optimize construction for robots. Right now we're optimizing robots for construction. Now I still think that's the right way to go, but that's the real transformation that will happen. So I am the technical side of the co-founding team. I've done leading technical teams for about 20 years. I'm also a former submarine naval officer, so appreciate the idea of building good teams. But I had the fortune of meeting my co-founder, Stephen Muck. He is also the CEO, owner of Raymond Construction Corporation, which is a heavy civil contractor in the Mid-Atlantic region. And he does bridges, roads, dams, locks, etc. And he happened to live in Pittsburgh, which is where Carnegie Mellon University is, where I spent my formative years working on autonomous vehicles, on autonomous helicopters, ships, and convoying operations in my time there as well. And I don't have to belabor the point. He saw the construction industry losing people. He saw many people retiring. He saw the productivity rates in this estimating department drop over the past 25 years. And he knew something had to give and something needed to get better. So he met me, and we went forward with searching for how to build on-site robotics. And our model is to, of course, do the work on site. We want to improve safety, increase productivity, and increase consistency, and most importantly, reduce scheduling risk, right? I think we'll all know that the big bang in savings is when you can finish the entire project weeks or months early and save the money associated with that. So our model is, of course, to continue doing that. We're going to do that through purpose-built applications to start with. So we talked about it earlier. There's nothing more painful than tying rebar. So for those who are not in the construction industry, you lay out rebar both direction, and in some cases, every single intersection has to be tied together before you pour the concrete for reinforced concrete. And by the way, most applications have 2 mats. So you have to lay it, tie it, lay it again, and tie it again. So we're talking hundreds of thousands to millions of ties per project. And so my partner thought that would be a great place for us to start, and I certainly agree. So we went ahead and made our first product, which we call a TieBot, which is a gantry-based autonomous rebar tying robot. It is full stack AI. You have computer vision to see the intersections, plan, and do the tying by itself. But with my partner being in construction and understanding how difficult it might be for them to adopt new technology, we tried our darndest to make as limited effort needed by the contractor. So there is no programming. You don't have to put in BIM. There's no pre-mapping. There's no calibration. There's no programming. You can show up and literally, if it's a small enough width, you can crane it directly off the truck, directly on the bridge, and you could be running in 5 minutes. But if you need to assemble the gantry system, we can go as wide as 117 feet long, and we can tie as many shifts as you want at the rate of about 1,100 ties per hour. That's about the equivalence of about 4 to 6 workers, and of course, we can tie day or night, rain or shine, etc. It's plug and play, as I think robotics can be these days. We've been in the field. We've been doing this for a while now. We've done over 31 plus projects, tied over 8.5 million pounds of rebar, which comes to about 2.5 million ties throughout the United States. And we certainly are looking to scale. We actually just shifted our business model to a robot as a service model. So we've been following that path that you guys have been describing in the past. So we've done basically pilot programs, and we have done leasing where we have had our folks with it, and now we have customers who operate the machine by themselves. And actually looking to grant money this year to part of the Build Back Better program in order to actually create what we would call the first ever construction supervisor course, right? So as you can imagine, if you look back in the early 20th century, the job of an electrician or mechanic never existed before, right? So we get to be, with us in the room here, get to be part of a new revolution where we're creating a whole new job category called a robot supervisor. So we have already several of those, and really I think leading the way in setting up that structure in place, and I'd like to see that grow. So as you can imagine, the construction workers who have our rebar tying robot said, when are you going to make the robot that's going to carry the thousands of pounds of rebar and place it on the deck before we tie it? So we agree that the next product that we're working on should be replacing this painful work. So this is not staged. This is actually a real job. As you can maybe see earlier in the background, we actually had TieBot tying on this job, and we were catching up to the workers placing the rebar. But this is the state of the art, guys. You grab rebar with bundles, you literally walk, and these are short rebars. Typical rebars are 60 foot long, so you're talking 5 guys walking on top of rebar in the morning dew, trying to bend over and place rebar for months at a time. It is devastating to their health. And if you ask many iron workers, they will tell you they don't want to do this job. They do not want to do this job. If our focus is every robot we build will have people with it. That's the right choice for many reasons, and most importantly, it's the right technical decision. And I can talk to you guys about that afterwards. So we've already built the second product called IronBot, which is going to lift, carry, and place rebar on job sites. This is our full-scale prototype that we finished last year, and we're happy to say that we will have our first commercial version at job sites at the end of this year, moving to scale starting next year. And so as you can imagine, placing and tying rebar with this robot will do about 80% of the rebar installation process on typical sites. And we've done time studies with our full-scale prototype, and of course we have lots of job data around TieBot. So we say that increasing the overall rebar installation process, which is typically estimated in pounds per man-hour, as the way the construction industry looks at it, at least 250% improvement, but most likely it's going to be in excess of 400% overall rebar installation improvements. And as you can imagine, we're not stopping here. Our plan is to take both TieBot and IronBot to the rest of the reinforced concrete market. So as you can imagine, our core technology, or core AI, does not know whether it's on a bridge, a building slab, a roadway, a tilt-up wall. It sees rebar and it ties it and it places it. It's that simple. I think we have lots of construction people who give demos on, and you run it for 3 minutes, and after a while you're like, that's all it does, guys. It just ties rebar, which is a good, for anybody who are the technical robotics guys, when it's a boring robot, it is a good robot. It's successful. So we are excited to be part of this, excited to be part of this community, and great to talk to you guys afterwards, because I cannot wait for all of us to be successful so that we can make that jump from having robots adapt to construction, to have construction and design adapt to robots, because that's the way we're going to transform construction. So I look forward to talking to you guys. And by this, we conclude the presentation for today. I really enjoyed the lineup. I don't know about you, but this was amazing. The panel, the startup presentation. I mean, MassRobotics today leading a cluster of around 400 robotics companies. We have more than 60 resident startups. We spun out 7 companies, 4 got acquired, 3 continue to grow. We have about 40 corporate partners, but the true stars are really the startups. So you in the room, you are the one that we built this organization for, and why all this community and ecosystem is helping you. So continue to innovate, continue to change the world, continue to add value, and open opportunities. So I know that for the ones online, we had some connectivity issues, so I do apologize out of our hand. But we are recording everything, and we will make the recording available. So if you miss any part, please come and check it. Few quick announcements. We do a lot of events, actually, and you can see on the slide. Those are some of the events. So actually, believe it or not, this Friday we are celebrating our 5th anniversary, and for that we invited the White House Secretary of Labor, Marty Walsh. He's the former mayor of Boston, and obviously we have a close relationship. He supported us early on. So he will be coming to MassRobotics together with an amazing panel, and they will be speaking about the future of work. April 7th, we have RoboSource, and this is really around suppliers and service providers for startups. So if you are a startup, either in the room or online, make sure to come to this event. It will be in District Hall, which is very close by here in the Seaport, and it will be an amazing event. May 10th to 11th, probably the largest robotics event happening in the city, Robotics Summit and Expo. This will be happening at the Boston Convention Center. Co-located with the event is the Healthcare Robotics Engineering Summit. I know that this is a construction event, but again, another vertical that we focus on is healthcare. And we have been running a Catalyst program, and we are hosting the closing event of this program at the Healthcare Robotics Engineering Summit. If you are in the city or around, or you are willing to fly in, I'd love to have you. Last but not least, in parallel to the Robotics Summit, we will have a Robotics and AI career fair in the same location. So if you are online looking for jobs, looking to join some of the companies, or even the larger companies, the partners and other large corporates in the area will be there. This is probably 3rd, 4th time we do the career fair, and every time it's oversubscribed, hundreds of people come in. We do have to thank all of our partners. So we started off back in 2016 with founding partners. We had 11 founding partners, but today we have close to 40 corporate partners. They are the one kind of support us, and more importantly, they are the one that give us a feedback about the market pulse, what the market is looking for, where the market is going. They are the one that get engaged with the startups. They are the one that supply the startups and help them about market insights. So for all of our partners, especially the ones who joined us today, Autodesk and Danfoss, thank you very much for your continuous help. And also, I would like to thank our team. I think Joyce, she went to the office, but Joyce is the one who really put this event together. I always call her the beating heart of MassRobotics. So she put this event together, and also acknowledge Tom Ryden, our executive director, is joining us today. Khalif on the AV, Sayu, Sherry on the front desk, all of our team. This amazing organization is running on the shoulders of those folks. So don't look at the fancy kind of people who are doing the easy things. It's all the people on the background. So thank you all for joining us today. Please stay in touch and let us know if we can help in any way. For the folks online, thank you for joining us today, and have a great day, evening, or night. Thank you.
And
for those of you who are here and staying, we have a little snacks and beer and wine for afterwards socializing. So please stay around for that. Lubrication, right. And see demos. Yes. So come see Matt's arm, Cleo's drone.